Let's start with question number 24. Factorize completely. Now that's expressions and it's going back to the brackets. Now let me just take you first to the textbook in factorization. And I first want to take you to the summary of this. And this you will find on page 108. And it's factorized when to use which one. Okay, so it's always two terms that you make one, three terms that you make one as soon as it's in brackets, four or more terms that you make one. And it's a very, very important part in algebra. So, and there's four types of factorize. There's common factor, there's difference between two squares, there's grouping, there's quadratic expressions, trinomials. I'll take you now to the correct one. This summary is just very important to identify which one to do. If it's two terms, always see if you can take out a common factor. And then if you can go further into difference between two squares. If it's three terms, first common factor and then further into trinomial. So there's two, there's three. If it's four more, common factor grouping. But usually this is where you will take out a common factor out of two terms, a common factor out of two terms, and then take a bracket out as a common factor. So just make sure that you always first go for the common factor. Okay. Now, if I take you back to the question paper, I must first take you back to show you which one, that we identify which one. Okay. So if you look at this one, then you see it's two terms. Now, this just looks like a common factor. And if I take you to the textbook, and I want to show you in the textbook where we are, I will take you to page 100. Okay, and let's just get the textbook 24. Okay, this is easy. I think you did it also in grade 9. So it's on page 100. We are in chapter 3. Okay, and remember, if you expand, you go there. And if you go back to the brackets, you factorize. Okay, so it's good that we see that also. So if you look at this one, it's just, I look for the, and I want to show, I did it in this question paper. It's where we write it as prime factors. And then we write it as also this two as prime factors. And then we only take the basis that's in both terms. So it will be 2, and we take the smallest index. So it's 2 to the power 3, which is 8. And then not 3, but a, and the smallest exponent is 2. And then b, and the smallest exponent is 1. And that is your highest common factor. And you write it in front. And then to get that middle terms, or the bracket terms, I just take the term and I divide, and I showed you there. And then I get that. And then I take this second term, and I divide by the highest common, and I get that. And there, that is working back to the brackets. Let's do it. Let's do it. Okay, so let's go to the question paper. Okay. So this is the highest common factor. So I start with x. It's only x is in both. So if I divide x minus 16, very simple. It's actually a grade 9 one. So I'm back at my brackets. And this was 2 terms. Now it's 1 term. Okay. This is a trinomial. There's no common factor to take out. Let's go and let's revise that. Very, very important thing in algebra. Okay, so let's just go to 24b. Let's just see if that was 24. Yes. Okay, let's see. Oh, there it is. And again, as I said, I did 2 or 3 videos and then it just collapsed. Okay, that is fine. Let's do it again. This is on page 104. This is still in chapter 3. This is factorized quadratic trinomials. Now, what I do, and I just want to make it a bit smaller, I divide it into 2 groups. I divide it into group, and it's just my way of talking. And I think, although it's difficult, it's a recipe thing. You see, you look, you follow the recipe, and you see a nice outcome. So I say I look at the sign in front of the constant, the term without an alphabet letter. If it's positive, for me it's in group A. And if it's negative, for me it's in group B. Okay, and I even want to do it like this. For me it's in group A, it's positive, and B when it's negative. Okay. Now, the one in the question paper is positive, so I'm going to focus on this example. So if you look at this example, and I'm going to start here. So basically what you do is you take this number in front of the x squared and the constant, and you break it up into factor pairs. So 1 times 1 is 1, that's easy. But 6 can be 1 times 6, 2 times 3, 3 times 2, 6 times 1. Now usually if this is 1 and 1, you don't have to swap it around. Okay, but for later on, I swap it around. Then you do the test. You take 1 on this side, 1 on this side. That's what I did there. And you cross multiply. So 1 times 6 is 6. 1 times 1 is 1. And if I add that, I get 7. I must get what? 5. Sorry, try again. Now let's try again. I take 1 and 1. I take 2 and 3. 1 and 1, 2 and 3. I cross multiply. So 1 times 3 is 3. 1 times 2 is 2. And if I add, because why do I add? Because I am in group A. We add. I get 5. Oh, bingo. I got it. 5. Now it's just the signs. In group A, signs are the same, but not always plus plus in both brackets. Both take the sign of the middle term. Now, what is the sign of the middle term? Oh, that is plus plus. But if the middle term is negative, then it must be negative, negative. Okay. Then the quadratic expression has x squared. Therefore, put an x next to the number of the first column. So, x. If there was a y squared y, we would have put y. But for now, no, it's not like that. And I don't think, yes, it's not the rule. It's the exception. Okay. And then don't forget, as soon as you write that is your first bracket. And that is your second bracket. And it doesn't matter if you write the one in front. They just look at the ingredients. If it's exactly a copy and paste. Okay, so that one is that one is that. And that's how you do it. But again, I repeat, go and practice it. Very, very important for further mathematics also. We bring trigonometry in, and the basic is that you must be able to factorize, especially a quadratic trinomial, page 104. Let's go back to the question paper and let's go and do it. Okay. So in this case, do you see what I see? Group A. I love it. Okay, what is this factors? Let's make it's 1 and 39. So 1 and 1, that's all. Now 39 is not having so many. It can be 1 and 39. It can be 3 and 13. And you don't have to swap around because it's 1 and 1. But you can see 39 is too big. But if you take this, okay, let's take this out. So I make 1 and 1, 3 and 13. So 1 times 13 is 13. 1 times 3 is 3. And 13 plus 3, it's 16. I got the combination. Now, the signs are the same in group A, but both takes a negative. Please don't forget that. And then, because it is x squared x, you look at that and it's x. And there is your first bracket, there is your second bracket. So it doesn't matter the order, they look at the inside. So as long as you have an x minus 3 and an x minus 13. So if somebody wrote x minus 13, x minus 3, he will also get his 2 marks. Okay, so please, it's very important in mathematics, and it's a more difficult recipe, but it's a recipe. Okay, and then the next one. The graph shows the speed of Wesley in a cycling race. Okay, now it's speed, time. You think of physical science. Calculate the total distance traveled. Okay, so let's go to the textbook. It's just all about distance. So I go to question 25. And as I said, I also did this one. Okay, but then I'm on track. Okay, so we come to all the stories. Okay, so I'm on page 283. That is chapter 6, 6.3. And there, do you see speed, time? And I'm just going to find the distance traveled by the van in 20 seconds. So that's the van. Now, there, the distance traveled by the van in 20 is area under the van graph. Calculate the area. So if you look at this one, you can say, I can either go and say, oh, this is this one. Okay, I just want to take a ruler. But this, if I look, 20, it's up to, okay, up to there. Okay, so do you see that this is a trapezium? So I can just go with the formula of a trapezium. And what is the formula of a trapezium? It's half height, sum of parallel sides. Okay, so if you look, you can just say, okay, what is the height? Can you see it's 6? There's the 6. What is the parallel sides? Now, if you look at 20 minus 8, I can say that this one, 20 minus 8, okay, that's 12. And that one is 20. Do you see? And that's 20 and 12. And it's a half, so I divide it by 2. That is the one method. The other method, I could have said I work out the area of this triangle and I work out the area of the rectangle. So the area of a triangle is half base, which is 8, times height, which is 6, plus this is 12 times 6. And I just add it and I get exactly the same. And that was on page 283. Let's go back and let's challenge that sum. Again, there's two ways of doing it. I can either use the triangles and the rectangle, or I could, and I'm going to make it a bit smaller, I could work with the trapezium. It's good that you know the formula of the trapezium. Okay, so I'm going to work with the trapezium, and I just want to show you a few things. So that is the parallel sides. So the parallel sides, just check that one. That one is 1. That one is 3. And what is the height? That is the height. And the height, what will be the height? 30. Just get that pen correct. Come on. So if I go with it, so I'm going to start. So the distance traveled is area. I'm just going to do it like that. Area under the graph. And that is going to be half height, sum of parallel sides at first, and then the other one I will just do orally. I don't want to do both because it happens that people do both methods and really don't do that. Okay, unless you struggle with one and you continue with the other one. Okay, so let's just substitute it. So 30 for the height, the parallel sides is 1 plus 3, and that is going to be 15. And if I'm going to times that with 4, that is going to be 60, and that's 60 kilometers. Now, if somebody did the triangle, I just want to show you that one. He could have worked with that, and then this base was, okay, I just want to show you. Do you see that these two triangles was exactly the same? Because both, and then the rectangle there. And as I said, I'm just going to do it orally. So it's half base, so the base was 1. So half base times height, and the height was also 30. Okay, so it's half base times height. Okay, so then it would have get 15. and then this length times breadth, so 1, so it's 30, and then half base times, and it's 15, and if you add up all that, you would have also get 60. Please don't do both methods, choose one, but if you cannot remember the formula for a parallelogram, then you can go with the triangles and the rectangle. Question 26. They give you a table. And then they say it's given that m is directly proportional. Okay, let's just say m is directly proportional to the square root, not square root of n. Okay, let's find the value of s and the value of t. So it's already proportion, direct, indirect. So again, I'm going to take you to the textbook. So let's just go there to question 26 and see where did I mark it in the textbook. Okay, it's here. It's on page 37 and it's chapter 1, numbers and operation, finding the equation of a direct proportion calculation. And remember, we're going to focus on the second method. Okay, although you can do it with the first one, the basic one, but we focus on this one. The height, h centimeters, reaches by an object thrown vertical upwards is proportional. Now, as soon as they just say proportional, they mean direct proportional to the square. Now, it's not square root of the speed, v meters per second, with which it's thrown. And then they give you also, it's almost like in a table, they give you two values. So, we start. The height is proportional to v squared. Because it's square, do you see? And then to make it an equation, we put in k. And then we take these values and we substitute it. Okay, there I substitute it to find the value of k. And then there is my equation. And as soon as I have my equation, I can find either v or I can find h. And in this case, they say find the height. So they've asked you to find h by the object thrown at 6 meters per second. So then I just put in or substitute v and I just get my answer. Okay, so page 37. So with this in mind, let's go back to the question paper. It's a little bit different ask, but don't let it throw you out. I'm going to show you how we do it exactly the same. Okay, so basically we start direct. So m is direct. If it was indirect, it would have been 1 over, but it's to the square root. So just make sure, square root of n. Then to make it an equal sign, I put k. Okay. Now, it's almost like they give you this. It's almost like they tell you n is 4 when m is 3. So I substitute it to get the value of k. So in the place of m, I put 3. In the place of k, n, I put 4. So I get 3 equals 2k. I divide 2. So the value of k, I think the decimal will be easier here, 1.5 or 1.5 or 3 over 2. So my formula becomes, and I'm going to substitute it. Can I show you where? I'm going to substitute it in there. So I have m, I want to keep to blue. So m equals 1,5 square root n. That is my equation. Okay. Now, in usual questions, they would have said, find the equation. But that's not. Now you still have to find it. So to find the other values. So now I come to this one. So if I come to this one, they give me n. N is 9. So in the place of n, I'm just going to put 9. And I get that m is 1.5 and the square root of 9 is 3. And then if I say 1.5 times 3, I get 4.5. Okay. And then I'm going to do my other one. Okay. You can write any space. And if you feel that you're writing next and you're afraid, then just draw a line and just continue. Okay. So I'm doing the same. So I say m is 1. I start with the equation. But now I just check. Now they ask me t. Now it's almost like you can put t already in that place. Okay, now I'm going to do this one a bit different. So I'm going to say m. What is m? M is 27. Okay, now I can just show you m, that m was actually s. So it was s that is 45. So I bring it in at the end. Here I'm going to bring it directly in. So I'm going to say 1.5, and then in the place of n, I'm going to put t. Okay, I just substitute in the place of m and n. Then it's 27 equals, okay, can I, before I can skip that step, sorry. I can divide by 1.5 and I divide by 1.5 and I get square root t is equal to 27 divided by 1.5 is 18. Now to get rid of a square root, you square both sides and then you get that t is equal to 324. So the value of s is 4.5. and the value of t is 324. Now, I will say it's a bit more difficult because they ask it differently. Okay, but the method is actually the same. So just make sure. Now, it seems to me here they gave you if you get s and you get t. And actually, if they saw that you got that 1.5, that constant, that's in the formula. Okay, and that's how you do 26. Let's go to the next one. Okay. Now, in this question, they say, by shading the unwanted regions, find and label the region R which satisfied the following inequalities. Now, when inequalities goes into graphs, we call it linear programming. Okay, chapter 7. And let's just find in the textbook again that question. Okay, so go to 27. I just want to see, here it is. Okay, and this is a nice one. This is basically, can I just show you the page? It's page 322. And the example I'm going, it's chapter 7, coordinate geometry and linear programming. It's actually a chapter which they say in the report that students struggle with. So please put a little bit more emphasis on these chapters. Okay, so we start 22. Draw a Cartesian plane, show the regions defined by the inequalities by shading the unwanted region. Okay, write R in the region required. Now, we use this a lot, and I think in paper 2, when I'm doing it, I'm going to use this principle also a lot. We don't make a table when we draw these graphs. So first we draw all the lines. We're first going to make it and put equal signs and first draw this line. Okay, so this one I started with. Now, the easiest method, if any line, it's not just a straight line, a curve, a parabol, if you want to see where it cuts the x-axis, you make y 0. Okay, so in the place of y you put, and it cuts at 3. Where you want to see where it cuts the y-axis, you make the opposite one 0, x 0. And it cuts the y-axis at 4. Okay, because you just need 2 points. So it cuts at 4 and it cuts at 3. Okay, so if I'm first drawing all the lines. If you want to see y equals 3x, then this method of cut, because it's going through the origin. And if it's going through the origin, it's not really, it's cutting the x-axis at 0 and the y-axis at 0. Then make a table. Please don't forget that. As soon as there's not a c value, then use the table. Then just choose a point, -1, substitute and get your points. And there is your line. Now, just take note. Can I just show you? In this one, there's an equal sign. That's why the line is solid. In this one, no equal sign, and that's why it's broken. Okay. And then the last one, y equals 0. So it cuts the y-axis, and it cuts at 0. And this is the line actually on the x-axis. And it's also broken because it's not having an equal sign. Do you see? No equal sign there. Okay. Now you draw your lines. Now when you come to the shading, now this is a very method that always works. If you look at this line, if you look at this, I'm going to, it's this line. Now there's 2 sides to this line. There's a going to the top, going to the bottom. So this is up, up, and it's almost like if I go there, it's down. Now, up will always be bigger. Down will be smaller. But what is the statement saying? Look, just let the y's on this side, smaller. So that is the wanted region. So this down is the wanted, but I shade the unwanted. And one thing I was reading in the report, they say students don't shade it nicely. Shade it from there to the bottom. Don't color it in. Just take a ruler and shade it. Okay. So now I'm going to take another color and I'm going to work with this line. Again, if there's two sides. If you look at this side, you will say I will go up. If you look here, you will go down. And don't forget what I said. Up is bigger, down is smaller. So if I look, y is smaller. That's what I want. I want this one. I must not shade this one. I must not shade this one. I shade the one I don't want. Okay. Unwanted. I shade the unwanted. And then the other one is very easy. Y is bigger because it's on this line. Up is bigger. That's the one I want. So check. Up, that's the one I want. I shade the unwanted. And there is the value of R. So if I go to the question paper, it was actually very nice because they didn't ask you to draw the lines. They gave you the lines. But just this example, and if you still want to do a few, it's on page 322. In part 1, Mathematics, grade 10, 11, y equals mx plus c. Okay, let's go to the next one. Documents. And we are going to the question paper. Not this one, it's already the next one. Oh, this is the one. And I'm just making it smaller. Okay. They say by shading, very important, shading the unwanted. Okay. So shade, block out the ones that you don't want. Label the region R following. Okay. So I must first find out where is that line. Y equals x. It's this line. It's this line. Okay. I'm just struggling to put it on that line. Okay, but it doesn't matter. It's this line. Now, I go and I say bigger. Now, again, can I just tell you? This is up, bigger. If I go to this side, it's down, then up. Down, that's smaller. Now, I want the wanted. The wanted is bigger. That is the wanted. I shade the unwanted, the other side. Now, they say, please do it thoroughly. Take from that whole graph, take a ruler. Don't color it in. Take a ruler and the whole line. Don't everywhere. Okay, the next one. X plus y, and can you remember, I said it in the 2020 papers. If you see x plus y 7, it's going to cut at 7, 7. Please don't. They love asking this. 7, x plus y equals 5. Then it will cut 5, 5. X plus y equals 10. Then it will cut 10, 10. Okay, they love asking this or giving this formula because it's easy. Okay, that's supposed to be then the easy one. So where's that line? That is the line. Okay, I want to get again my ruler. That's the line. Okay, and again, I have two sides. I have a side that's going this. Let's call this up. You don't have to. If you want, write it in pencil, but shade in pen. Shade in pen. So up is always bigger. This is down. I don't want to shade in there. And this is smaller. Okay, so to this side. This. Now, I want the smaller. So this is the wanted. And I must shade the unwanted. So take again your ruler. And from there, shade nicely. Don't shade half of it. Shade everything. And then take your pen. Okay. Actually, they should have also put this one, but doesn't matter. Take your pen and write R. Okay, that is the required region. Okay, so write R. So not so difficult. And again, they would have gave just for the shading, because it's just shading. So it was, say, 1 for this, 1 for the shading, and to find out. Please label your region. And then I come to this question, and that's on page 370, because they say exterior angle of a regular polygon. So I'm at angles. That's chapter 8. In the textbook, if I look, it's going to be 28. So let's just see, where is 28? This is in the textbook, and there was almost one like this in 2020. So this is regular polygons, and as I said, chapter 8 geometry. And here is the question like this. Very nice, very straightforward. Okay, so it's just saying a nonagon is with 9 sides. Calculate the interior, but it's this one, B. Each angle of another regular polygon is 150. This one is more difficult because they give you the interior. Then you must, with a straight line, first find the exterior by saying 180 minus 150, and that's 30. You see? So meaning that this one is 30. And then you will say 360 divide 30, and that's 12 sides. Okay, 37, and this is still in part 1. Let's go to the question paper. Okay, and there, make it a bit. They gave you the exterior, and I like making a picture because it just helped me. So it's like, it's just, okay, they could have gave me the interior, but they didn't. They gave me the exterior. That line is in there. So they tell me the exterior is 24. Just get the pen correct. And I know all the exteriors, or it doesn't matter what polygon it is, always is up to 360. The sum of the exterior angles is always 360. Regular, irregular. And if I divide it by that 24, I get 15. So there is 15 sides. And again, if they saw you did the division, and then for the 15. And that's how you will do question 28.